The moment a spear gun fires underwater, everything wrong with the design becomes immediately visible. The shaft has one job: travel straight, maintain energy through the water column, and arrive at the target with full force. Open-track spear guns give the shaft room to whip laterally at the muzzle, where the enclosure ends and water resistance takes over. Energy that should travel forward disperses sideways. The fish gets away. An enclosed track spear gun channels the shaft through the entire stroke, contains the lateral movement, and delivers the full stored force directly along the axis. The mechanism works the way physics intended because the track refuses to let it work any other way. If engine oils were spear guns, 5W-30 is the enclosed track. And the reason that matters is exactly the same as it does underwater. When the engine asks the oil to deliver everything it has at the worst possible moment, a film that bends under pressure is not protection. It is the absence of protection dressed up in a laboratory certification. Kinematic viscosity is the measurement laboratories use to describe how an oil resists flow at a given temperature. The standard test runs at 100 degrees Celsius, which is 212 degrees Fahrenheit, and the results come out in centistokes. A lower number means the oil flows more freely. A higher number means more resistance to flow, which translates directly to a thicker, more structurally stable film between two moving metal surfaces. At 212 degrees Fahrenheit, a modern fuel economy oil rated 0W20 carries a kinematic viscosity of roughly 7 to 9 centistokes. 5W30 at the same temperature carries roughly 9.5 to 12.5 centistokes. The difference between those two ranges is the difference between the open track and the enclosed track. Both films are present under normal conditions. Both are doing their job. When the engine is cruising at highway load on a cool morning, neither one is failing. Push the test toward 150 degrees Celsius, near the 300 degrees Fahrenheit threshold that represents real-world temperatures under sustained extreme load, and the advantage shifts to the heavier grade in ways the simple kinematic viscosity number does not fully capture. The viscosity index of an oil describes how much it thins as temperature climbs. Counter to what most drivers assume, 0W20 oils typically carry a higher viscosity index than 5W30 because spanning from the near freezing cold start behavior of a 0W grade to stable 20-weight film thickness at operating temperature demands either an extreme viscosity index base stock like polyalphaolefin or a heavy loading of viscosity index improving polymers. 5W30 does not need that polymer scaffolding to the same degree. The 30-weight base oil molecules are physically larger and structurally denser at baseline, which is why 5W30 carries a higher high temperature high shear rating. The enclosed track holds its geometry not because it has a higher viscosity index, but because it starts from a heavier molecular foundation that does not depend on polymer reinforcement to reach the film thickness the engine requires. Under normal driving conditions, a 0W20 oil maintains the lubricating film between every contact surface in the engine with room to spare. Bearing journals, cam lobes, lifter faces, all of them receive adequate separation between the metal surfaces. The two tracks perform identically when the target is close and the water is still. Run that same engine hard. Sustained boost from a turbocharger holding cylinder temperatures above 250 degrees Fahrenheit across a long on-ramp pull. A 3,000-pound trailer behind an aging four-cylinder on a mountain grade in July, the engine fighting gravity and momentum simultaneously, bearing loads multiplying with every foot of elevation. At that point, the 0W20's film leans heavily on viscosity index improving polymer chains to maintain its 20-weight thickness at running temperature. Under extreme high temperature high shear contact conditions, those polymer chains compress and can temporarily collapse their viscosity contribution, a behavior that becomes more pronounced the harder the engine works. The base oil underneath those polymers is lighter molecular architecture than what 5W30 starts from at baseline. That film thins. Clearance between the journal and the shell narrows toward contact. The spear starts to wobble. 5W30 at the same conditions is still operating at a physical margin the 20 weight was never given. The case for thin, fuel economy oils is not dishonest. A 5W-30 or 5W-16 oil will improve fuel economy on a new engine running a standardized corporate average fuel economy test cycle on a dynamometer. Those test numbers are real within that context. The context is the constraint. A dynamometer test cycle is not a 700-mile tow across the desert in August, nor a 150,000-mile engine with bearing clearances that have widened from decades of normal wear. It is not a turbocharger spinning at 200,000 revolutions per minute, dumping heat directly into the oil, lubricating the center housing bearing. High-mileage engines develop wider bearing clearances as the journal and shell surfaces wear microscopically over hundreds of thousands of power strokes. That widened clearance needs a thicker oil film to fill the physical gap and maintain hydrodynamic separation. Running thin oil in a high-mileage engine is applying the geometry of a new engine's specification against the physical reality of worn surfaces. The math does not work. Towing applications generate sustained bearing loads. The certification test sequences do not replicate. The sequence tests used to certify 5W-30 and 5W-16 verify performance under controlled laboratory parameters. Nothing in that certification covers the thermal and mechanical loading of a loaded trailer behind a crossover climbing 8% grades for 45 continuous minutes. 5W-30 is not a specialty product for unusual applications. The time-tested middle weight has protected engines across every climate, every duty cycle, and every service interval since modern multi-grade oil chemistry was standardized. The enclosed track did not become obsolete because lighter options arrived on the shelf. It stayed exactly where it was, doing the same work it always did for every application that never stopped needing it. The cheapest mechanical insurance policy available is not a premium brand or an extended drain interval or an aftermarket additive. Matching the viscosity grade to what the engine is actually doing under real-world load, not what a dynamometer test cycle says it should be doing, is the move that keeps metal surfaces separated when the temperature climbs and the load gets serious. When the load is real and the heat is real, the track has to hold. 5W-30 holds.